Designing distributed systems is like orchestrating a symphony where each instrument plays its part, but they're all spread out across different locations. These systems are the backbone of modern applications, enabling everything from social media to online banking. But what exactly goes into creating these complex structures? Let's dive into the principles, challenges, and best practices that shape distributed systems. First, let's talk about the principles. One of the core principles is scalability. As user demand grows, a distributed system should seamlessly expand to accommodate that growth. This means designing systems that can handle increased loads without sacrificing performance. Think of it like adding more lanes to a highway during rush hour. If a system can't scale, it risks becoming a bottleneck, frustrating users and potentially leading to downtime. Next up is fault tolerance. In a distributed system, failures are inevitable. Servers can crash, networks can go down, and data can become corrupted. The key is to design systems that can continue to operate even when parts of the system fail. This often involves redundancy, having backup components that can take over if something goes wrong. Imagine a plane with multiple engines. If one fails, the others keep it flying. This principle is crucial for maintaining reliability and ensuring that users can access services without interruption. Now, let's address the challenges. One significant challenge is network latency. In a distributed system, components communicate over the internet, which can introduce delays. This latency can affect user experience, especially in real-time applications like gaming or video conferencing. To mitigate this, developers often implement caching strategies, where frequently accessed data is stored closer to the user, reducing the time it takes to retrieve it. Another challenge is data consistency. In a distributed environment, multiple copies of data may exist across different nodes. Ensuring that all copies remain synchronized can be tricky. This is where concepts like eventual consistency come into play. Instead of guaranteeing that all copies are always identical, systems can allow for temporary discrepancies, with the understanding that they will converge over time. This approach can improve performance, but requires careful consideration of how to handle conflicts when they arise. Best practices for designing distributed systems include using microservices architecture. By breaking applications into smaller, independent services, teams can develop, deploy, and scale components individually. This modular approach not only enhances flexibility, but also allows for easier troubleshooting and maintenance. Each microservice can be optimized for its specific function, leading to more efficient overall performance. Another best practice is to prioritize monitoring and logging. In a distributed system, understanding what's happening across various components is crucial. Implementing robust monitoring tools can help identify issues before they escalate, allowing teams to respond proactively. Logging provides a trail of events that can be invaluable for debugging and understanding system behavior. Finally, embracing automation is essential. From deployment to scaling, automating processes can reduce human error and increase efficiency. Tools like Kubernetes can manage containerized applications, ensuring that resources are allocated effectively and that systems can adapt to changing demands. In summary, designing distributed systems is a complex but rewarding endeavor. By focusing on scalability, fault tolerance, and best practices like microservices and automation, developers can create robust systems that power the applications we rely on every day. The challenges may be significant, but the principles and strategies available make it possible to build systems that are not only functional but also resilient and efficient.